This video lesson is an introduction to trigonometry. And trigonometry, though it sounds so fancy, is just the study of triangles and angles in them, and the sides in them as well. And so today we're going to take notes on some of the intro stuff about trigonometry. And the first point is how to label triangles. So on your notes sheet, I'd like you to fill this in. All vertices, those are the corners, are labeled with capital letters, and they're usually consecutive, like ABC or CDE or DEF. They don't have to be, but they typically are. And all sides are labeled with lowercase letters. So you can pause the video at any point as you're filling in your notes if you have to go back, if you want to review something, or if you just want to pause while you're writing stuff. But I'm going to move ahead. The third point is that the side and vertex facing each other. So I'll show you what that means. Those are given the same letter, but we know that the vertices are capital and the sides are lowercase. So for instance, and I'm going to ask you on your second slide to label these, this side here, the one that I've highlighted, is opposite vertex D. What makes it opposite? Well, first up, this side is the one that is not touching this angle. This angle D is touching these two sides, but it's not touching this one. And so it looks like they're facing each other. Those are the two ways to look at that. That one is opposite vertex D, and thus it has the same letter, but lowercase. And if you want to pause the video for a second, try to label the other ones based on where you think they go. Give it a try, but I'm going to go ahead and do that now. This side here is touching angle D, it's touching angle F, it's not touching angle E. That's the one that it is opposite from, and so that is side lowercase e. And you probably know, even by process of elimination, that thus this side here is going to be called F, but it's opposite side, or angle F. So that's lowercase f, that's the side. Okay, cool. The second point is that in right triangles, there are special names for the sides. So I'd like you to write these two things down. Again, you can pause at any point if you'd like to. So this is a right angled triangle because it has a right angle. That will be indicated with this little square in the corner. That's a 90-degree angle. So I'm going to start from the point of view of angle A because it's going to change depending on what angle I am looking from. But suppose my vantage point is angle A. I'm looking from this one here. That's my point of view. So first up, this one is actually not dependent on what's my point of view. The hypotenuse is always the longest of the three sides, and it's always the one that is opposite the 90-degree angle. That's always called the hypotenuse. But there are two other labels, and those ones depend on which point of view I am taking. So from the point of view of A, the side that's opposite, we already talked about that, it's the side that is not touching angle A. It's this one here. This one here is the opposite side. And the adjacent side is, well, it's the third one, but it's the non-hypotenuse side that is touching A. Hypotenuse is always labeled first because we know it's the longest, we know it's opposite the 90. The adjacent is the non-hypotenuse side that is touching A. So these have the labels hypotenuse, opposite, and adjacent from the point of view of angle A. The reason that I keep saying from the point of view of angle A is because if we changed our vantage point and instead we were looking from angle B over here, well, the hypotenuse would stay the same because the hypotenuse is always the longest side and it's opposite the 90. It doesn't matter if we're looking from A or looking from B. That's still the hypotenuse. What will change is that now the opposite side, the side that's not touching angle B, is over here. So before, for angle A, this one was opposite. For angle B, this one is opposite. And that makes this side here, the non-hypotenuse side that's touching, that is the adjacent side. So you can pause at any point to make sure that your notes are filled in. But I will move ahead just as a quick recap. From angle A, that's the opposite, that's the adjacent. And from angle B, this one is the opposite, it switches, and this one is the adjacent. It switches, but the hypotenuse stays the same. So that's what we've done so far. That's a quick recap of how to label things in a right angle triangle. And finally, the last thing for this intro lesson is that we use those sides to name and fill in sides of three trig ratios. These three trig ratios we're going to use next class in a more specific way. And also they will be used. They are useful because they are also buttons on your calculator that you may not have seen before. But I'll take you through what those three things are. So remember, this is we're going to take a look from this angle A. From the point of view of angle A, that's the hypotenuse. We know that this one here is the opposite, and this one down here is the adjacent. So there are three trig ratios, and this is what they are. The sine, this is the same as the button on your calculator, that's sin, of angle A. So it's also written sine A. I'll show you that in a second. So the way this is usually written is like this, sine A. It looks like it should be pronounced sin A, and that's the button on the calculator, but it's just an abbreviation. And it means that sine is the ratio of the opposite side divided by the hypotenuse. Why would we do that? Well, eventually we're going to learn how to use this to find the value of a missing side. But for now, we're just going to label things and figure out the right ratios. The cosine of angle A, typically written like this, cos A, is the adjacent over the hypotenuse, and tangent, which is written tan A, is the opposite over the adjacent. So there are three different ratios, and for today, we're not going to find missing values using them yet. We're just going to learn how to label them. And just to show you that on this next slide, if we were looking from the point of view of angle B, we know that it switches which one is the opposite and which one's the adjacent. That's opposite angle B, and that's adjacent. So sine B is always opposite over hypotenuse. What changes is which side is the opposite. Cosine B is always the adjacent over the hypotenuse. It just changes which one's the adjacent. And tan is always opposite over adjacent. What changes is which one's the opposite and which one is the adjacent. So a quick way to remember this, I'd like you to write this in, is this, which is an acronym. It stands for a bunch of different things, and I'll show you what they are. SOHCAHTOA. That's how it is pronounced. SOHCAHTOA. It's fun to say. And it's a helpful reminder as to what those ratios are. What this means is that the S, which stands for sine, is equal to the opposite, the O, over the hypotenuse. SOH tells you that sine is the opposite over the hypotenuse. It's a helpful reminder. Ka tells us that that's cosine is equal to adjacent over hypotenuse. And as a reminder, to tan is the OA, opposite over the adjacent. Just a quick way to remember that. So keeping those in mind, you will have questions to practice today like these. So depending on which one is the one we are talking about, it will swap which one is the adjacent and which one is the opposite. But on your handout, it has asked you to find the ratio of a bunch of different things, like sine of P or cos of Q. If you'd like to pause and give those a try, you can. I'm going to take you through how to do those in just a second as well. So the way I have done this is I started off looking only from the point of view of angle P. And if I did from angle P, this is the opposite, this is the adjacent, and I know that this over here is the hypotenuse. That's always the hypotenuse. And so when I'm filling out all of my ratios for sine P, remember that sine is the opposite over the hypotenuse. That's 16 over 20, and I could reduce it, but I could leave it like that for now. Cosine of P is the adjacent over the hypotenuse, so it's adjacent over the hypotenuse. And tangent of P is its opposite divided by its adjacent. And I did the Q ones next, so I changed my labels. But you could just sort of look at P and decide, like, okay, for P, I know that that's the opposite, and I know that that's the adjacent. When I'm asked for sine of Q, I can just look at Q and say, okay, I know that that's the opposite of Q, and I know that that's the hypotenuse. So I can fill these in as well. Again, if you want to pause and give it a try, you can. But from Q's point of view, sine Q is the opposite over its hypotenuse. Its opposite is 12, and the hypotenuse is always the same. Cosine of Q refers to its adjacent. And tan of Q is its opposite over its adjacent. So that's how we fill those out. And in some cases in today's work, you will see examples that look like these, that have a number in them. And there are two bits to this. First up is that this angle over here, I can find that because the sum of all three angles in a triangle adds up to 180. So I can find this missing angle because it's going to be 180 minus 90 minus 57. So it's clear that when I'm asked for the sine of 57, it's talking about its opposite, the hypotenuse. And when I'm talking about cosine of 57, I'm talking about its adjacent. and the hypotenuse. When I'm talking about tan of 57, I'm talking about its opposite and its adjacent. But I also can answer other questions because there's another angle in here, and I can figure out that that angle is 33, and I can find those ratios as well. So that is how you fill out the trig ratios based on angles, based on names, based on sides, and hopefully you were able to fill out your notes and you can try the work as well. Thanks for watching.